Welcome. I'm David Morin,
I'm Sarah McLean.
and today we are going to be showing you how red cabbage can be used as a pH indicator.
First, you're going to need some red cabbage, which you probably got from the grocery store or something. Then you're going to get a pot filled with water and boil it, and then add the cabbage to it, and boil for about 10 minutes or so the red pigments from the cabbage can be taken out.
And this red pigment is actually called anthocyanin. It's a dye within the red cabbage, and we're attempting to isolate that and take that from the red cabbage and put it into the water. It will have a neutral solution, so it'll have a pH of about 7.
Let's see us pour some in here. Get ready for the next one.
And what we did was we isolated this dye from the red cabbage, and we have strained out all of the cabbage, and then we have taken and poured it into a cup. Now what we're going to do is we're first going to add lemon juice, also known as citric acid.
Has about a pH of 2 or so, 2-3.
And we'll add it right in, and you can see what happens. It goes from a purple to a brighter color, a pink-red type of color, as you can see here. And then we'll prove that again with another acidic solution, vinegar, or commonly known as acetic acid. So again, we start with the purple dye that we isolated from the red cabbage, and we'll add some vinegar.
It has a pH about 4.5, 5.
So it takes a little more vinegar for it to have the color change. And it's not as bright, but the color change still occurs because it's still an acidic addition. Now, conversely with the base, instead of turning into a brighter color, we're going to notice a darker color change. So we've taken some baking soda and some water in equal parts. We're stirring it up, and what we're going to do is we're going to add it. So we start with our purple color, yet once again. Got it? And then we see it turn from a purple to a green-blue, kind of like an aqua.
Mm-hmm.
And
this has a pH
color
about 8 too, so you can tell that's why it's changing to a darker color.
And lastly, we're going to add some soap, which is has a more basic solution to it.
It has a pH about 11.
So we'll start with our purple dye, as we have every other time. We'll add it, we'll stir it, and then we notice it turns not to a green, but more to a blue-black, because it's a stronger pH.
And you can't even tell too much from the purple. You have to take a very close light to it to see how it's a slight blue.
So, why exactly is this occurring? Well, it's occurring because of the dye that is located within it. This dye is called anthocyanin, as mentioned before, and it's a structure within the solution that allows the color to change due to the varying pH values. When in a basic solution, the anthocyanin has an extra hydroxyl, and in an acidic solution, it has more oxygen due to the addition of the hydrogen ions from the acid. The OH removes the positive charge of the structure and causes the absorbances of the protons to change to a greater wavelength, thus making it a darker color and makes it appear more green, blue, black. The addition of the hydrogen ions makes the solution more positive. This creates a shorter wavelength, giving it a brighter color. And that is why this occurs. Thank you.